Okay, guys, I want to take a minute and show you some graphs that you need to be able to interpret for wavelength frequency. So if you look on my board right here, this is wavelength, this is frequency. So as the wavelength gets bigger, the frequency is getting smaller. So that is an indirect relationship. Okay, so if you move over here, this is energy and this is frequency. So as the frequency gets higher, the energy gets higher. And this is a direct relationship. So these are two graphs that you will need to be able to talk about a little bit more. So let's look at the electromagnetic spectrum. So if you go back to probably elementary art school or art class, you're going to remember Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. And that's what we have now. That is our visible light. But there's more to the electromagnetic spectrum than just visible light. So look over here at the radio waves. If you look at the buildings, this means that radio waves are the size of skyscrapers. They're very large. So these are your AM, FM radio waves. So these are very large, low frequency waves. So there's very little energy involved. So we're always constantly being bombarded by radio waves, and we're not harmed by them. So there's low energy. Microwaves, same thing. They're about the size between humans and butterflies. Again, large waves, low energy. Okay, if we scroll on down to over here is gamma rays. Gamma rays are the size of an atomic nucleus, the nucleus of an atom. They're tiny. So very high frequency, a whole lot of energy. And I always tell my students, remember Marvin the Martian on Looney Tunes, and he's always trying to blast Bugs Bunny with the gamma rays. It's high energy. Gamma rays is actually what doctors use for cancer treatment and radiation. And so they will pinpoint the cancer tumor and they will blast it in different directions with the radiation, because if they use just one beam, it would damage all the tissue around. So they divide up the radiation into multiple points and they blast that tumor. So gamma rays, super high energy. X-rays, they're not quite as high energy, but they're still very high. If you go to the dentist, they make you wear the heavy lead vest to protect your thyroids and your lymph nodes for the X-ray. That's why. It's because it's still high energy. These waves are about the size of atoms. Ultraviolet UV radiation, that's from the sun. Still quite a bit of energy if you look at the frequency of it. They're the size of molecules. This is why sun can cause cancer. It's because there's still quite a bit of energy involved. Okay, so you should be able to kind of interpret a electromagnetic spectrum based on this. Again, your frequency, 10 to the 4th power. That's quite a large wavelength, small frequency. Go over here to gamma rays, 10 to the 20th. That kind of gives you the perspective of it. Okay, so visible light is a form of electromagnetic radiation. We've already discussed that. X-rays, microwaves, radio waves, and the sun. But I want to talk about electromagnetic waves, and there's something quite unique about an electromagnetic wave. So let me scale back a little bit. And you have to kind of picture this on an XYZ axis. So you have the typical transverse wave that goes up and down. But electromagnetic waves is actually formed with two transverse waves, one going up and down, one going side to side. So as they're going up and down and side to side, they are actually pushing each other through space. And this is actually why we can see light travel through a vacuum or space. So down below, I'm going to give you instructions on how to complete the FET